Hi everyone, my name is Sanjeev. In this video, I will talk about CloudHub 2.0 features and its architecture. I will also talk about how CloudHub 2.0 is different from CloudHub 1.0. CloudHub 2.0 is fully managed iPaaS platform where you can deploy your APIs and Mule integrations. You can focus on developing your APIs and Mule applications, and you can deploy these APIs and Mule application in the CloudHub 2.0. CloudHub 2.0 will manage, secure, and monitor your APIs and Mule applications. You don't have to worry about setting up the platform. CloudHub 1.0 use AWS EC2 instance to deploy the Mule application, but CloudHub 2.0 use Kubernetes-based cluster, and it is based on Kubernetes container-based architecture. It deploys the Mule application inside Kubernetes lightweight containers. CloudHub 2.0 provides the platform for deployment across 12 regions globally. Like it provides two regions in US East, two regions in US West. You can choose the region that is close to you. You can reduce the application latency. CloudHub 2.0 have easy to use UI. You can use this UI for deployment and other configuration. We have terminology changes in CloudHub 1.0 and CloudHub 2.0. We used to configure VPC virtual private cloud for single tenancy. Now in CloudHub 2.0, we need to configure private space, and this private space is based on Kubernetes cluster. If we want to connect to on-prem data center, we need to define single tenancy private space in CloudHub 2.0. In CloudHub 1.0, we used to configure VPC and dedicated load balancer for a vanity domain and to configure the certificate inside dedicated load balancer. In CloudHub 2.0, we have ingress controller. It is inbuilt feature of the Kubernetes cluster. So in CloudHub 2.0, we use ingress controller as a load balancer. CloudHub 1.0 used AWS EC2 instance, and we used to call worker. We deploy the application inside worker, and we need to configure one worker, two worker for a high availability. In CloudHub 2.0, we call replica because CloudHub 2.0 used Kubernetes, so it is using the Kubernetes terminology. So worker is called replica, and we configure the one replica, two replica, three replica based on the high availability configuration. CloudHub 2.0 architecture. Here is the CloudHub 2.0 architecture diagram. CloudHub 2.0 have two parts, control plane and the runtime plane. We developed the integration apps and API that will be deployed on CloudHub 2.0. We use Runtime Manager UI to configure and to deploy the Mule application on CloudHub 2.0. MuleSoft Runtime Plane use platform services. These are shared services. These services manage the infrastructure and the deployed Mule application. So platform services manage, secure, and monitor the deployed Mule application. CloudHub 2.0 is elastic cloud of replicas that have Mule instances and runs the integration apps. Control plane manage, secure, and monitor the Mule app. Runtime plane have replicas that has Mule runtime and Mule application. It communicates to the control plane through ingress controller. MuleSoft provides redundant platform. It runs the platform services on at least two data center, and each data center is at least 60 miles apart. All communication between platform services and CloudHub is secure using SSL. So any communication that happens between control plane and the runtime plane is secured by SSL. MuleSoft dynamically scales the infrastructure and built-in services based on the load. CloudHub 2.0 use the rolling update to apply the infrastructure fixes and security patches to ensure the zero downtime. So when applying the infrastructure fixes or the security patches, mule application does not have any downtime window. They can always be accessed. CloudHub 2.0 use AWS EKS cluster and deploy the application inside container. So each replica is deployed in a separate container and each replica has a specific size like zero point 0.1 vCore, zero point 0.2 vCore, 1 vCore, 2 vCore, etc. Each replica provides isolation because it runs on a separate container. Each replica is monitored independently and it runs in a specific region. CloudHub 2.0 use ingress controller as a load balancer. So it load balance the request from different replicas with the help of ingress controller. CloudHub 2.0 provide built-in security to protect services and sensitive data. It supports the encryption, firewall control. It also restricts the cell access. CloudHub 2.0 supports the clustering of application for application scalability. Clustering is supported using Hazelcast, so it shares the in-memory data between replicas with the help of Hazelcast. And request between replica is load balanced using HTTP internal reverse proxy server. CloudHub 2.0 provide high availability, scalability through redundancy, intelligent healing, and zero downtime updates. Whenever CloudHub 2.0 detect any hardware failure, it migrates the application to the new replica. CloudHub 2.0 supports zero downtime deployment with the help of rolling update. In the rolling update deployment, old version of application keep running while new version of the application is deploying. Once the new version of application is deployed successfully, CloudHub 2.0 switches the request to the new version of the deployed application. CloudHub 2.0 supports more granular vCore size. Like in CloudHub 1.0, we cannot assign 0.5 vCore, we cannot assign 1.5 vCore, we cannot assign 2.5 vCore, we cannot assign 3.5 vCore. CloudHub 1.0 supports 0.1 vCore, 0.2 vCore, then 1 vCore. In CloudHub 2.0, we can assign more granular vCore. So after 0.1, 0.2, we can assign 0.5. And after 1 vCore, we can assign 1.5, we can assign 2.5, we can assign 3.5 as well. In CloudHub 2.0, corresponding to vCore, the total memory is little more here. Like in 0.1 vCore, in CloudHub 1.0, total memory is 1 GB, but in CloudHub 2.0, it's 1.2 GB. Here in Cloud 2.0, we have more flexibility when we are assigning vCore size. We can choose more granular vCore size, but the maximum vCore size that we can assign to any replica, that is 4 vCore. Maximum vCore size that we can assign in CloudHub 1.0, we can assign 16 vCore as well. So maximum vCore size is limited to 4 here. If we need more processing power, we can do the horizontal scaling and we can use more than one replica when we are deploying the application. Shared spaces. CloudHub provides shared space in each region. It's a multi-tenant environment where you can deploy the application. This shared space is shared by other tenants as well, and they also can deploy the application. So applications are deployed in a public cloud. Shared space does not require any setup. Application deployed on shared space use CloudHub.io domain, and you cannot configure the custom certificate. Application deployed in a shared space provide isolation by separate container. Application deployed in a shared space does not share the data. If you don't need separation from public cloud, and if you don't need to connect to your own data center, if you don't need to configure custom certificate, and if you can use the CloudHub.io domain, you don't need vanity domain, then you can use the shared space. But if you are looking for single tenancy for your application and you need to connect to your on-prem data center, if you need to configure vanity domain names and you need to configure custom certificate, and if you want to use only private endpoint, And if you need static application source IP addresses, then you require private space. You cannot use shared spaces. But if you are okay with the CloudHub.io domain, you don't need a custom certificate, then you can take the benefit of a multi-tenant environment where there is no setup required and you can deploy your application in shared spaces. In CloudHub 1.0, we used to configure BPC and DLV to provide a single tenancy environment where we can deploy the application. In CloudHub 2.0, we can provide a single tenancy environment using private space. So we need to define the private space. It's a private isolated logical space where you can run your application. You can create multiple private spaces in a same or different region. You can create connection between private intranet and private space, and this whole setup can work as a single network unit. You need to just create a connection between your private internet and the private space. In each private space, we define a private network where applications are deployed. We can create connection from private network to external network. And in CloudHub 2.0, we use Anypoint VPN or transit gateway to create the connection. CloudHub 2.0 only supports Anypoint VPN and transit gateway. We can define TLS context. We can configure multiple TLS context, which means application can have multiple public URLs. TLS context can be used to define the domain, and you can also use mutual TLS, two-way SSL. We can also configure the firewall rule for inbound and outbound traffic. So incoming traffic can have the firewall rule, and outgoing traffic also can have firewall rule. By default, CloudHub 2.0 supports port 80 for HTTP and 443 for HTTPS, and the traffic can come from anywhere. But you can configure the firewall rule for incoming traffic. For example, you can only accept the HTTPS traffic. CloudHub 1.0 does not support outbound firewall rule. CloudHub 2.0 supports the outbound firewall rule as well because of egress controller. You can configure the egress controller. With the help of egress controller, you can configure the outbound firewall rules as well. By default, it supports any destination on any port, but you can configure, for example, only TLS or SFTP protocol to a certain destination. In private space, we also define environment and business groups. In private space, you can define application path rewriting. You can configure the path and it can point to the path where application is accessible. So you can have different path and that is pointing to a path where application is accessible. When we deploy the application on CloudHub 1.0, we need to make sure that application name is unique. But we don't have such requirement when we deploy application on CloudHub 2.0. CloudHub 2.0 appends the unique ID and shard to the application name. For example, if we are deploying the My App application to the CloudHub 2.0, CloudHub 2.0 generates a 6-digit number for the application and it append to the application name. It also append the shard. Private space or shared space have a shard associated with the it. Private space and shared space have a 6-digit number shard associated with the private space or shared space. So it append the shard. In case of shared space, it also append the shared space number like 1 or 2. So if we are deploying the application name my name, the DNS record becomes my name dash unique ID, that is ID that is generated by CloudHub for the application, unique ID, 6-digit ID, and then it append the dot shard. The shard associated with the private space or the shared space. And in case of shared space, it also append the hyphen and the number. So which number of the shared space in a region. Then it append the region, and at the end it's the domain name .cloudhub.io. In this slide, I will highlight the difference between CloudHub 2.0 and CloudHub 1.0 features. CloudHub 2.0 does not support persistent BM queue. We can use the Anypoint MQ instead, or we can use any other external MQ. Persistent BMQ is not supported in CloudHub 2.0. Even if we are using the feature of clustering, if the last replica goes down, data shared between replica will also lost. We can use the Anypoint MQ to handle the use case that require persistent BMQ. Load balancing. CloudHub 2.0 use ingress load balancer. It does not use dedicated load balancer. CloudHub 1.0 does not support downloading the load balancer logs, but in CloudHub 2.0 you can download the load balancer log. So you can download the ingress load balancer log. CloudHub 2.0 does not support TLS 1.0. It does support TLS 1.1, 1.2 and 1.3. Networking. CloudHub 2.0 supports AWS Transit Gateway to create a connection between other private network, other VPC. It does not support Direct Connect and VPC peering. Direct Connect and VPC peering were supported in CloudHub 1.0. CloudHub 2.0 have the egress controller where you can configure the outbound firewall rule. In CloudHub 1.0, there was no way you can configure the outbound firewall rule. CloudHub 2.0 supports static IP at private space level. CloudHub 1.0 supports static IP at application level. CloudHub 2.0 supports VPN redundancy by default. It supports high availability. So in case of maintenance, reduce the downtime because of its high availability. Application capabilities. CloudHub 2.0 does not support data graph. It does not support custom notification. Custom notification using CloudHub connector was supported in CloudHub 1.0. Custom notification is not supported in CloudHub 2.0. Log forwarding was supported in CloudHub 1.0 as well, but you need to create a support ticket to disable the CloudHub log, and then only you can forward the log to the external system. In CloudHub 2.0, you only need to add appender, and logs can be collected by external system collector, log collector, and you can forward the log to the external system. CloudHub 2.0 supports mule clustering. So in case you are using 2 or 2 plus replica, you can choose the option of clustering and data between replica will be shared. Internally, it uses Hazelcast to support the sharing the data between replicas. Sharing of data will be in memory only. CloudHub 2.0 does not support auto scaling. CloudHub 1.0 supports auto scaling. CloudHub 2.0 has limited runtime manager alerts. You can have alerts for deployment failed and deployment successful. For other monitoring alerts, you need to use Anypoint monitoring. If you want to enable or disable a schedule, or if you are modifying the scheduler, you need to restart the application in CloudHub 2.0. In CloudHub 2.0, to protect the property value, you do not need to pass the property through mule artifact.json file. You can protect the value in runtime manager by protect option. It uses one-way encryption. You cannot get back the value, but you can assign the new value to the property file. There are some other differences between CloudHub 2.0 and CloudHub 1.0. CloudHub 2.0 does not support mule runtime 4.2 or less. It only supports mule runtime 4.3 or above. CloudHub 2.0 supports CPU bursting, and it does support the CPU bursting for replica size of less than 1 vCore, and it's support by default. In case of CPU bursting, replica can use more CPU than allocated in case of heavy load. So if application is getting many requests and it need more CPU, then it can use the more CPU than it's allocated. This allocation is for a smaller span of time and it's not guaranteed. So CPU bursting works for a replica size less than 1 vCore and works by default and is based on availability of the extra CPU. CloudHub 2.0 does not support Anypoint security tokenizer policy or other WAF policies. In CloudHub 2.0, if you want to monitor vCore usage, you can do that in Access Manager at business group level, and this usage monitoring is not available in Runtime Manager. In this slide and next slide, I will describe how to secure Mule application and API in CloudHub 2.0 and how to monitor the Mule application and API in CloudHub 2.0. Some of the point we have already discussed in previous slides, but I will summarize in this slide at high level how we can secure the API and Mule application in CloudHub 2.0. In private space, we can configure the firewall rule, we can configure the inbound firewall rule. For example, we can configure that API and application will only accept HTTPS traffic from a specific source. In CloudHub 1.0, we cannot configure the outbound firewall rule, but in CloudHub 2.0, we can configure the outbound traffic rule as well. For example, we can configure outbound traffic would be only on TCP or SFTP protocol to a specific destination. We can configure multiple TLS context in private space by adding certificate. We can configure up to 10 custom TLS context. TLS context can be used for mutual TLS or mutual SSL. In private space, we can remove the all public endpoints. That means application or API can be accessed only from inside private space. It cannot be accessed from outside. We can configure last mile security. By default, CloudHub 2.0 terminates the HTTPS at ingress controller. But with the last mile security option, we can secure the traffic between ingress controller and application. Request from the ingress controller to the application will be sent on HTTP connection. We can also configure SSL forwarding. If we choose the option of SSL forwarding, then client certificate detail will be sent to the application. An application can use this certificate detail for client authentication or for any other validation. At private space level, static IP can be used for whitelisting. Other than these security configuration options in CloudHub 2.0, we can also use the API manager to configure the policy to secure the Mule application and API. Monitoring in CloudHub 2.0, how to monitor Mule API and application in CloudHub 2.0. Runtime Manager provide alerts on deployment failure and deployment success only. For any other monitoring, we have to use Anypoint monitoring. In CloudHub 2.0, platform collects the application log automatically. We can also configure the custom log, like we can change the log level. CloudHub 1.0 does not support downloading the load balancer log, but in CloudHub 2.0, you can download the load balancer log. That means you can download the ingress log. In CloudHub 2.0, you can send the log to the external system. You do not have to create a support ticket to disable the CloudHub log. You can add the log appender in log4j, and you can forward the log to the external collector. Like you can forward the log to the Splunk by adding the Splunk appender. In CloudHub 1.0, if you want to forward the log to the external system, you need to create a support ticket to disable the CloudHub log first. But in CloudHub 2.0, you only need to add appender in log4j and you can forward the log to the external system. This slide describes the CloudHub 2.0 limitations. In CloudHub 2.0, application size could be up to 350 MB. Number of properties could be 300. Application property key and value size could be 1024 characters. HTTP header length could be up to 32K. Custom TLS context per privacy space 10. That means you can create a 10 custom TLS context per private space. Number of inbound and outbound firewall rules can be up to 180 separately. You can have up to 5 transit gateway connections. You can have up to 10 VPN connection. And if connection is not redundant, then you can have total 10 connections. And if they are redundant, then you can have up to 5 connections per private space. You can create up to 100 private spaces per organization. You can create up to 200 environments per business group. Platform API rate limit is 15 requests per second per remote IP address. In this slide, I'm providing the information regarding CloudHub 2.0 roadmap. I have gathered this information from different MuleSoft conference meetings. The status information regarding CloudHub 2.0 roadmap that is provided in this slide is subject to change. Initial CloudHub 2.0 release, CloudHub was not supporting non-HTTP protocol, but now it does support the non-HTTP protocol. For example, now it supports the healthcare protocol HL7. In CloudHub 2.0, now you can configure the domain name based ingress control. So instead of configuring the different application IP addresses in egress control, you can configure the SaaS domain name. Like for example, you can configure the salesforce.com in egress control. CloudHub 2.0 does not support auto scaling and elastic provisioning. CloudHub 2.0 is based on Kubernetes, and Kubernetes does support the auto scaling and elastic provisioning. But CloudHub 2.0 still does not support the auto scaling and elastic provisioning. Support to auto scaling and elastic provisioning is in the roadmap. We will get the support for the auto scaling and elastic provisioning in CloudHub 2.0 in the future. Migration from CloudHub 1.0 VPC to CloudHub 2.0 private space is in the roadmap. Tooling to migrate the application from VPC, CloudHub 1.0 VPC to CloudHub 2.0 private space is in the roadmap. We should get that in future. CloudHub 2.0 does not support custom notification. MuleSoft is working on to support the custom notification in CloudHub 2.0 as well. They might not support the custom notification by using CloudHub connector, but they will provide the support for the custom notification in some different way. CloudHub 2.0 also does not support partner manager, and support for partner manager is also in the roadmap. This is all in this video. In this video, we talked about CloudHub 2.0 features. We talked about shared space and private space. We also talked about the difference between CloudHub 2.0 and CloudHub 1.0 features. And at the end, we talked about the CloudHub 1.0 limitations, future roadmap, and current status of roadmap. This is all in this video. If you like this video, click the like button and subscribe the channel. Thanks for watching. Thank you very much.